So, as we are preparing our P&IDs, we should do our best to ensure that our system is well protected against operational issues. We have seen how this is implemented in previous videos by ensuring a fully rated system by specifying the worst design conditions. Also, we have seen that we can add shutdown protection to prevent the upset scenarios, and we can also mitigate the upset event by adding a PSV to relieve the pressure in the system and hence protect it from overpressure. However, applying all these concepts to every piece of equipment and to each portion of the plant would require a very exaggerated cost. If we consider exaggerated design conditions, we will end up with equipment with much greater thickness and with heavy foundations, which can heavily affect their cost. If we consider all protection instruments, ESD systems and shutdown shall all be considered as cell-free and shall be added to every portion of the plant. This will also be very costly. In addition, there should be some room for operator intervention in order not to shut down the plant for unnecessary scenarios, which means less production and less profit. If we added a PSV to each portion of the plant or for unnecessary scenarios, we shall end up with a huge number of PSVs and a huge relief load, which means a huge relief system that shall be sized based on exaggerated relief loads. All this means not just higher costs, but even a greater burden on operators to maintain the PSVs or the instruments or shutdown valves. In some cases, they may be a source of operational issues themselves. For example, a shutdown valve may close in a position that causes disturbance to the process. Unnecessary ESD protection actions may paralyze the operators and make their mission to operate the plant more difficult with no strong justification. A PSV may also leak or open at a pressure that is less than its set pressure if the PSV wasn't well calibrated, which shall introduce an unnecessary process interruption. That's why a process engineer should always try to optimize and balance the plant safety, cost, and operability. However, it's always important to ensure that all the upset scenarios where we are afraid of an accident or some kind of damage to the equipment are well addressed and that the plant has enough protection. That's why in most projects a hazard and operability session, or in other words, HAZOP, is conducted. Through this session, the project team from different backgrounds sit with each other, identify the risks and project deviations in each portion of the plant. They shall also check out if the design addresses the above upset scenarios with proper safeguards, and if it doesn't, then they shall add applicable recommendations in order to fix these scenarios and respond to them properly. For even more critical points, we may need to conduct a further study against the current layers of protection and check their reliability against the severity of the deviations they are addressing. And based on the result of this study, we shall end up determining the cell rating or the safety integrity level rating of the shutdown protection system, instruments, and shutdown valves.